the short-term conditions in the interplanetary space, near-Earth environment, and in all the Earth's other atmospheric spheres, particularly caused by the solar activity and its associated electric and magnetic outflux. So, unlike the weather that we experience on the Earth's surface, most of the space weather effects remain in the upper atmosphere and ionosphere, and beyond in space, and are not readily perceptible to us. To understand how the variable solar activity affects the near-Earth's environment, geomagnetic activity, and the atmospheric system, we need to first know and understand solar activities. The sun, in addition to light and heat, also emits charged particles, particularly from sun's corona, in the form of plasma. They spread out with high velocity through interplanetary space and called as the solar wind. It also emits X-rays, UV rays, and highly energetic protons and electrons, conspicuously during an event called solar flare. This solar wind also brings with them the tightly coupled magnetic force lines, called the Interplanetary Magnetic Field, IMF. The plasma, the radiated X-rays, UV rays, and the magnetic fields makes the interplanetary conditions to vary. They give rise to various phenomena as they interact with other fields and particles. Thus they define the space weather. The solar wind interacts with the geomagnetic field and defines its shape. The particles get into the magnetosphere and causes different currents to flow and results in geomagnetic field variations. They also cause different inductive electric fields. Geomagnetic variations lead to geomagnetic storms. Induced electric fields disrupts various services on Earth. Enhanced charged particles damage space assets. Radiations and electric fields influence the ionospheric electron density distribution. Space weather means a lot more. To learn and understand the various aspects of space weather, visit our site www.spaceweather.tech.